here's section 7.3, exercise 28. And in exercise 28, they just ask us to decide whether we would prefer the disk method or the shell method, explain our reasoning. So we're given a function y equals 4 minus e to the x, and the region, they say, looks kind of like this. It goes down here to 1 point something. When y is 0, x is the log of 4, I guess. So that goes through the natural log of 4, and at 0 it goes up here at 4. And they're saying that this is going to get rotated around the x-axis. Okay, so if it's rotated around the x-axis, I'm going to draw it a couple times here. So we have this log 4. We have 4 there. We got that. So if we go with the disk method, we go perpendicular to the axis of rotation. So here's disk. And if we go by the shell method, we want to make things that are parallel, slices parallel to the axis of rotation. And so what I like about this is I'm marching along x. I'm going from 0 to log 4. What I like also about this is I just used the function they gave me, y equals 4 minus e to the x. So here, I would set up something that is 0 to log 4. Now, I have to know this log 4, in which case, I had to solve 0 equals 4 minus e to the x. And so e to the x equals 4, x equals natural log of 4. So I had to know that. That's something that's sort of a drawback. It wasn't obvious necessarily that was log 4. But then with the shell method, I just need my 2 pi RH. So 2 pi, then my r is just x. That's nice. And then my height is just the function 4 minus e to the x dx. Okay, so that was nice, and we'll get back to that. Now with the disk, all right, I'm going like this, so I have to split up the y-axis, so 0 to 4, and I'll have a dy there, and it's just going to be pi r squared. Well, in this case, r squared is that distance out to here. It's the x value, which means I need to solve for x. Oh, well, that's a bummer, but hey, here I had to solve for x as well. So, what's the difference? And so solving for x, I would have x equals, got a little ahead of myself, e to the x equals 4 minus y, and so x equals natural log of 4 minus y. And so I would have the natural log of 4 minus y squared. Now, for us, we have a problem either way. So, which one would I prefer? Well, if I get to use Desmos to evaluate the integral, I really don't care, and I probably like this one better. If I have to evaluate the integral, right? I don't know this one. That looks nasty. Because I could do a substitution, but I still have log of u quantity squared. I don't know what the answer to that is. I might be able to look it up, but then I might be able to look this one up as well. And so, I don't like the antiderivative here. Now here, um, the antiderivative actually, you multiply through, you get 4x, not a problem there. Um, but then you get this minus x e to the x. Well, calculus 2, I know how to do this one. So I guess in the long run, that would be my choice, just because if I have to do it, I know how to do this one from calculus 2. This one I'm still not so sure about. And so I might choose this one. Now, given that, in calculus 1, we don't know how to do either of these antiderivatives, then I think I'd still choose this one, just because, I like setting things up where I slice up the x-axis. So I think I would prefer this one. So I'll go with the shell method on number 28.